Hello once again, this is teacher King David. We're going to see part 3, lesson number 2, about multiplication of complex numbers. Last time, we saw how we can add complex numbers and how we can subtract complex numbers. So now, we're going to see how we can multiply complex numbers. For example, let Z1 be A plus BI, and Z2 be C plus DI. How can we multiply Z1 and Z2? So now what is Z1 and Z2 here? It is just a multiplication, which is A plus BI into bracket C plus DI. The way we do it, we just expand. You remember when we are expanding, for example, when we are, like we have A plus B, C plus D. How can we expand this one? Just a matter of expanding. It is A times C, which is AC, A times D, which is AD, then B times C, which is BC, B times D, which is BD. Just expanding. So that's what we're going to do here. So it is the same thing, but remember, I squared is -1. So A times C, that is AC. A times DI, that is ADI. Then BI times C, that is BCI. BI times DI, that is BDI squared. And I squared is -1, which is BDI squared. So now the answer here is AC. So here we have I. So we're going to take it as imaginary part. Write AD plus BC into bracket I, because this one has I and that one has I. So I squared is -1, which is -BD. So this is -BD and AC, we take it as a real part. So that is AC minus BD, then plus AD plus BC into bracket I. So that is Z1 times Z2. So example, let's have examples. Of work out. We have A, Z1 times Z2 for Z1 equal to 1 plus 3i and Z2 equal to 5 minus i. So how can we try A? We have Z1 equal to 1 plus 3i and Z2 equal to 5 minus i. We're going to find Z1 times Z2. Z1 times Z2, that is 1 plus 3i into bracket 5 minus i. So what will be the answer? 1 times 5, that is 5. 1 times -i, that is -i. 3i times 5, that is 15i. 3i times -i, that is -3i squared. So now the answer is 5 minus I plus 15, that is 14i. Then I squared is negative. Negative, that negative comes positive, that is +3. So now the answer is 5 plus 3, because 5 and 3 are real part, which is 8, plus 14i. So this will be Z1 times Z2. B, given that Z equal to 3 plus 4i and W equal to 1 plus I, find Z times W. We're going to find z times w. Our z is 3 plus 4i. Our w is 1 plus I. So what is z times w? It will be 1 plus I, which is w. You know that multiplication is commutative. So times 3 plus 4i. So now it is just a matter of expanding. And remember that I squared equal to negative 1. 1 times 3, it is 3. 1 times 4, that's 4i. Then I times 3, that is 3i. I times 4i, that is 4i squared. So here, we take 3 plus, this is imaginary part, 4i and 3i. We add, we get 7i. I squared is negative 1. Negative 1 times 4, that's negative 4. So we add the real part, 3 plus negative 4. That's negative 1 plus 7i. So that's the answer for z times w. Okay, then after that, let me try to give it like another number, c. For z equal to 3 minus 5i and t equal to 1 minus 2i, find zt. So z times t. How are we going to find z times t? Z times t, we have the value of z, which is 3 minus 5i. We have this value of t, which is 1 minus 2i. So now, 3 times 1, it is 3. 3 times negative 2i, negative 6i. 5i times 1, minus 5i. Minus 5i times negative 2i. Negative times negative becomes positive, that is 10. I times I, that is I squared. So now this is 3. This is imaginary part, 6i minus 5i, that's negative 11i. Then 10i squared, I squared is negative 1, it will be negative 10. So 3 and negative 10, when you add them together, it becomes 3 minus 10, which is negative 7. Then minus 11i. So this is zt. So that is the answer of z times t. So let me give the exercise here to see if we can try this one. Exercise number 1. Given that z equal to 2 minus 3i and w equal to 1 plus 2i, then find a z times w, b w times z. Number 2, for z equal to 1 plus 4i and t equal to negative 1 minus 7i, find zt. So try this one to prove that you have understood this part 3. Let us meet in part 4. May God bless you.